What's up, 8th grade? It's Mr. Wilsey here, and Miss Herrera and I are putting together virtual versions of the labs you would traditionally do in the classroom, since y'all unfortunately can't do them. So, to start, I have this Play-Doh here, and I'm going to set the camera up here so you can watch what I'm doing. I'm going to make... We're learning about topographic maps, so I'm going to make something that you might make a topographic map of. Which topographic maps are used to make two-dimensional pictures of things that might be three-dimensional in real life, like mountains or hills, valleys. So what I'm going to make an island. Imagine that this is a model of a volcanic island, like Hawaii or the Aleutian Islands off the coast of Alaska. Imagine it's a convergent boundary and one plate is subducting under the other, and as it subducts, we get this rising magma forming this volcano here. So notice that I put and I made that a little bit not straight, so let me straighten it out a little bit. But notice that at the top there's a crater, and that's going to be important later because I'm going to show you how to label the crater on the map. When seen from above, that's what it looks like, but obviously it's three-dimensional, so how do we make this three-dimensional object seem three-dimensional on a two-dimensional paper that we could pack up and put in our backpack or in our pocket if we were traveling somewhere? For example, let's say I'm a developer and I want to build like a resort on the side of this island because I want people to come and spend money, go to the beach and enjoy themselves. I need to know what a good place to build it. And obviously, if I build a resort here, that's not going to be so good because it's steep. It would be better to build it here where it's more flat. The only way I can know that is if I get an idea of the topography before I go and start making plans. To do that, construction companies and whatever those people are that design houses, architects, they will look at topographic maps and use them to help them. So don't just think that this is something that only people that go hiking or camping will need to understand. So imagine that this is the ocean. I'm going to draw some waves in there so it looks very ocean. Before you say it, no, my waves do not look like birds. Somebody said that in my first period, and I'm still mad at them for that, so shut up. Don't be rude. Anyways, so what I'm tracing right now is the edge of the island. And the edge of the island is going to be at 0 feet above sea level. We measure the elevation above sea level, because if you think about it, the ocean is the lowest point that you could ever interact with. So there, you've got the basic shape of what the landmass looks like. And if I showed this to, like, you might be like, well, that's what a map is. Yeah, but if I show this to you, it really doesn't give you an idea of the topography. It just gives you the shape of the outside. So what I'm going to do now, see if I can do this in a way that you can understand. I'm going to measure this mountain, and it is approximately 8 centimeters high. So let's see. Let's do every 2 centimeters up. I'm going to make a new contour line. 2 centimeters is going to be our contour interval, but that's obviously not... Well, I'll get there later. Anyways, and the top is 8 centimeters, so I have placed marks on the side of this that represent where our contour lines are going to be traced. So let's see if I line this up here. Then these are going to be right here. Okay, so what I'm going to do, now I'm going to take this dental floss and I'm going to cut through my model to make my first contour line. And you're going to see why I'm doing this in a second. Then after I cut through, I can take this part off. And that's basically the base of the island right there I just cut out. So I'm going to put that aside. Now we've got this part, and I've got my notches, so I'm going to line them up with the tick mark I put here. I marked it earlier. And now I'm going to trace around this part here. So you can see I'm drawing a line that's going to give somebody an idea of what this island looks like, even if they haven't actually seen the island in 3 dimensions. Oh, yeah, if you feel inclined to do this yourself, and you happen to have Play-Doh, that would be awesome. If you do it and you send me a picture, I will, like, do a happy dance. I will, like, I don't know, I'll shave or something. Like, I'll shave my beard. No, I won't. I'm not shaving this beard. That's never going to happen, despite you all asking me. It's not going to happen. But if you guys do this, I will be, like, ridiculously happy. Or if you take a potato and cut it up, you can do something similar. So anyways, I cut off the next layer, and I'm going to put that aside. Again, I'm going to line up my notches, which I've only got one left. See how I made this easy for myself, guys? Take it from me. Sometimes in life, you got to work smarter, not harder. All right. Anyways, let me just cross that over here. So I'm tracing around the edge. So you can notice every line I draw, every point on this line is the same elevation above sea level, every single line. So now the last but not least, I'm going to cut our last part out, if I can do this without ruining everything. And yes, I can. I'm just going to knock the whole page over here. Okay, last one. So I'm going to place that here, line it up, trace around the edge. So I measured 2 centimeters up the side of the mountain as I measured. So each of these lines should be the same elevation change. So if this is 0, well, I'll get there in a second. Let me rebuild my model so you all can see it next to the next to what we ended up with. Okay. Anyways, so here's the model now, and you can see if you look at this from above, that's what it looks like, and that's what the map looks like. And even though it's still just a map, it's not the same as a three-dimensional picture. Everybody looking at this can be like, oh, clearly it's flat over here because it's spread out, and it gets a little steeper here, and it goes up to this this peak. This is clearly some kind of a mountain or a volcano. Oh, and last thing I forgot to do, remember when we traced this, there's a crater in the center, right? So the crater is what we call a depression. Now, a depression, we are not meaning that the volcano is sad, as I said yesterday, but that would be hilarious. Anyways, what we mean is it's an area that kind of dips down, so it's the crater of the volcano. I'm going to draw it here. And you might be like, but that just looks like another contour line. Yes, but the way I show that this isn't higher, that it's actually going lower, I'm going to draw some tick marks here, pointing inward, to show that this is actually a crater that is going down. That's how you distinguish that from just a regular contour line. Anyways, so let me place that back. Now, so again, let's say this is 0 feet above sea level. 0 feet. Make sure you include a lot of y'all did not include your units on your assignments today. Of course, the assignment. Make sure you do that. So let's say that every one of these lines, because again, the distance between this part and here is the same as the distance from here to here. It's 2 centimeters of elevation change every time. Obviously, this represents a much bigger area. Let's say that it's 100 feet above sea level. So that would be 0 feet. This would be 100 feet, then 200 feet, then 300. And this is a depression, so it's not 400 up there. That's an area that's going down. All right. And, well, technically, that's the top of this. So that would be 400. But then the area here is going to be dipping down. So I'll label that 400. So contour interval. We talked about it yesterday. I'm not sure if everybody understood or not. The contour interval is the difference in elevation change between one line and the next, which clearly it goes from 0 to 100, 100 to 200, so the difference is 100 feet. That means that even if the lines weren't labeled, you'd be able to go, oh, this one's 100, this one's not, 100 plus 100 is 200, then 300, 400, etc. That's how you use the contour interval. Now, real quickly, I want y'all to notice over here, the lines are close together. That means it is a steep slope. Over here, the lines are really far apart. That is a relatively flat area. It's a flatter area. So right here, you might get a beach. So that's a beach area. That might be where you want to build your little beach resorts and invite all your friends over that like to go to the beach. I don't know about y'all, but I just really, really like the beach. So, the beach is good. Anyway, so over here, you got a steep slope. Let's say weathering erodes away this side of the mountain. You might eventually get a cliff few years later. So if I'm a designer anyway, or an architect, and I'm looking at this map and I want to design a building, I'm not going to build it here or here or here. I'm going to build it over here. So hopefully that helps you understand how topographic maps work a little bit more. So again, if you do this at home with Play-Doh or with a potato that you cut up with a knife or something like that, of course, bear in mind, I'm not at, if you use a sharp object, have adult supervision there. But, send me a picture of it or something, email me one or something, and I'll just I don't know, I'll do a dance or something. I don't know what I can do to bribe you. I can't do much. Maybe I'll send you a video of me doing jumping jacks or doing like a super dance or something. Anyways, thanks for watching, and y'all have a wonderful day, and make sure you do those questions that we left you in Google Classroom. Thank you for being awesome. All right.